Hello, welcome to the podcast. This is Bristol Real. I'm Val.
I'm Jerome.
And I'm Tom. Today we spoke to Margaret Cooke, who's a chartered structural engineer with a particular interest in conservation and sustainable materials. She's a director at both Integral Engineering Design and ModCell, and she's a guest lecturer at the University of Bath.
First, we had a chat about what ModCell and Integral actually do. They're two separate companies. ModCell specialise in sustainable design and construction, buildings using randa, straw bale and timber. Really, really interesting stuff. And then Integral, on the other hand, are slightly more general, but similar sort of ethos behind it. Then, moving on from that, we actually got on to ethical engineering in general. So we were looking at intelligent use of materials, vying away from using concrete and steel and more towards the timber and randa that I mentioned a moment ago. Her work as a conservation engineer is actually really interesting too, because she's chief structural engineer at Wells Cathedral, which is cool. We talked about some borderline catastrophic situations involving pottery casts and church spires, as well as making sustainable housing mainstream. That ties in quite nicely with ModCell.
Brilliant. Hope you enjoy it. Welcome to the podcast. Today we're with Margaret Cooke, who's the director of Integral and ModCell. Thanks for joining us on the show.
It's a pleasure.
We first talked to Dr. James Norman, and he actually mentioned Lilac and ModCell and Integral numerous times.
Right.
And so we wanted to find out a little bit more about projects.
Mm-hmm.
And so we contacted you.
Okay.
So do you want to give us a little bit of background on what you've worked on, what ModCell is, what Integral is?
Okay. They're two quite separate worlds in many ways.
Mm-hmm.
So I separate my life between the two. So with my Integral hat on, it's a small consultancy, maybe 15, 16, 17 people. We've been going 15 odd years, and we cover all sorts of things. So my world is actually a world of conservation. I'm the cathedral engineer for Wells Cathedral, and we take lots of grade 1 listed buildings, mostly in a slightly derelict and perilous state, and make them usable again in various forms. So there's lots of projects there that we could talk about. People like the National Trust and the Prince's Regeneration Trust, and the sort of people who take existing buildings in sad states and do something interesting and exciting with them. Mm-hmm. Integral as a practice covers then a huge range from that kind of thing right through to new build projects, but particularly looking at sustainable new build. So we were one of the first consultancies to become expert in solid timber design, for instance, which when we started doing it was very new and no one really knew how to do it, and we had some of the very first uses in this country and built the biggest office block at the time in this country and that kind of thing. So other people are now catching up, but it's quite an interesting place to be. But it also was the start of Integral. So Tim, who's one of my fellow directors, was doing this world of sustainable new build, and I was doing this world of sort of green and hairy conservation. And we realised that we were actually using exactly the same materials but for completely different reasons. Okay. So very low embodied energy materials, local materials, all of those things which the conservation world never lost sight of, and the new build world was remembering how to use. And I suppose from that very naturally falls ModCell. So ModCell started with it was actually a brainchild of Tim, Tim, my fellow director, and a guy called Craig White, who's an architect in Bristol. The two of them are good mates. They've worked together for many years, and they started saying, well, surely there must be a better way to build them. We can't, steel is wonderful, concrete is great in the right circumstances, but there has to be something better for bog standard, ordinary housing and office blocks that doesn't rely on masses and masses and masses of embodied energy. Timber is great, straw is a brilliant insulant. Surely you must be able to combine those two things to make a very carbon neutral, even carbon negative building, locally sourced and all of those things. So they were the ones who got together and went, wow, let's give it a whirl. Did the first panels on the side of UE, looked at them, realised that they, within a year they didn't decompose or anything like that, and got quite interested in it, and there started a series of grant-funded research projects with the University of Bath, which culminated. The biggest build project so far has been Lilac, but actually it's now growing again, and the next projects are going to be. We've just done a smallish project in Bristol, which is the first market available straw bale homes. So, you know, with ordinary mortgages and ordinary people buying them off the shelf. So, you know, literally you go to a estate agent and they say, here's a straw bale house, you could have this one. And people go, yeah, please. So that's, I mean, that is a first, because Lilac was brilliant, but it was very much people who were very keen to make a statement and do things that were a bit different. And it's partly about the materials, but it's also about the way they've set themselves up as a community and things like that. So it has all sorts of social benefits. They couldn't be more ordinary, these houses. They look like a council estate, and that's kind of what they are. And actually that's kind of what ModCell should be. It shouldn't be something which is special only for people who have the time and the energy to think about what they're doing, but it should be easy and simple just to go and buy an ecologically friendly house without having to think about it. So the next one from the 7 houses, the next one is 50 houses in Bristol, and the one after that is 70 houses in Frome. So they're starting to really build volume, which is kind of where it should be. Ordinary houses for ordinary folk, built in a, you know, what we now think is a slightly unusual way, but of course all we're doing is winding back to where my world starts, back in the world of people who, you know, you build with what you've got to hand, and you build in a way which is, you know, you shove mud and straw together and you get a cob house if you're in Devon, and you shove stone together and you get a stone house if you're in the Cotswolds, and you know, so you work with whatever is available locally.
James was very excited about the Lilac project. He talks about it consistently throughout the episode. Do you want to give a couple more details to our listeners on what that project entailed?
Yes. So, from our point of view as structural engineers, it was 20 houses. So they're built into, I think, I wasn't the project engineer for it, so my involvement was more from the ModCell side. But I think there's six blocks. So some 3-bed houses, some 4-bed houses, some flats, and they're, you know, timber frame buildings. They happen to have straws and insulation, but essentially they're timber frame buildings with lime render, and they look a little bit different. They look like ModCell. They look classic ModCell buildings with an inverted commas. So you go on the ModCell website and you'll see a classic ModCell building, sort of quite square. But that's what they liked. That was the aesthetic they were after. They wanted that very classic shape. But the thing that was interesting and different about them really was said before, not just the material choice, but so what they've done. The details are really complicated, so you always need to go and talk to the guy at Lilac who knows it inside out and whose brainchild it was. But it's quite a complicated arrangement whereby you kind of own shares in it rather than owning a building in this place, and the amount of shares that you own is also slightly dependent on what salary you own. So there's no reason why, just because you're a cleaner, you know, in a single parent, you can still have and own a house on the Lilac project, and your contribution towards it will be smaller than the person next door who happens to be a High Court judge. But and when the High Court judge leaves, he would take more money, and when the single parent cleaner leaves, he would take less money. But that, so it's you can still live in this place and do your bit of contribution and things like that. And they have things like it's not passive house, but it's kind of set up on those lines. So people don't have their own post boxes, their own letter boxes in the front door, so you don't have drafts and that kind of thing. They have a central house where your post gets delivered to, and the postman has a key to the door and pops the post in there. They don't have their own washing machines. You go to the central laundry and do your washing there. They don't have spare bedrooms. So if you have guests come and stay, they stay in the common house. So that means that every house in the whole place doesn't have one more bedroom than they actually need. So it's a much more, you know, you can get a lot more people into a smaller space if you agree to share some of those communal facilities. So it's an interesting place, sort of materially, but also socially and financially. There's a lot going on there, which is quite mould breaking. The issue that Lilac have got is it took them 7 years to get from inception to actually anywhere close to building. And most housing associations don't have the time or the energy or the expertise to actually follow it through, and a lot of co-housing projects fall down because of that.
Do you think in future you'll see more projects like that, or do you think we'll stay in this situation where we have one family has a house and they have X many spare rooms and they all use one kitchen, but they don't use it efficiently?
I'd like to think there might be. And what is interesting is that one of the things that's coming out of Lilac is an understanding of one of the things they're kind of not selling commercially, but selling as an idea, is that you could take the way that they set it up and replicate that. That's a replicable model.
Mm-hmm.
So they are now teaching other housing associations about what they've done, the things that have gone well, the things that have gone badly, the things where you could make it simpler, and getting the word out. So, and then the other thing that's happening is that the government are pushing quite hard at the moment. It'll be interesting to see what changes after the election. But at the moment, they're pushing the self-build. The self-build market has always been a fairly chunky proportion, actually, of the housing market. But most people who self-build because they've got, again, the time, the energy, the wherewithal, the intelligence, the ability to build for themselves. So you go find a plot, you go find an architect, you do your design, and that's actually quite a lot of energy. And then everyone else, if they want a new build house, is stuck with the kind of Barratt Homes of this world, which is fairly limiting in terms of you get what they give you, and they will give you the absolute minimum they can get away with because they're after getting a profit. Mm-hmm. So what the government is doing is pushing, what are they calling it? It's a way of self-building where you can specify more closely exactly what you want. So you get a plot, and on your plot you can choose from. There are 3 or 4 housing providers, one of whom for one of those projects is ModCell, as it happens, but will be several others. And you can say, well, I'd like ModCell house type A, please, but I'd like kitchen type B and roof shape C, and I'd like it actually to have, rather than the 3-bedroom model, I'd like the 4-bedroom model.
Yeah, so you make it.
So you can pick out sort of from standard features. You can pick out the bits that you want, and you can choose to have the one that could be extended later if you've got the cash, but you don't have the cash right now. So you can, that's the plan, is that you'll get a standard plot size, but you'll be able to pick more easily what you want. But what the sort of base, there's one called Igloo. So what Igloo will provide is all the services to the door, and all you have to do is connect them in, or all your builder has to do is connect them in. So they will do the infrastructure stuff. So it's quite, it's an interesting world. There's quite a lot of things are changing in the world of housing. I think that people have realised that the Barratt Homes of this world are part of a solution, but they're certainly not all of the solution by any stretch, and that we have to find better ways of doing it.
Mm-hmm. You mentioned like square buildings and standard buildings, and this building you said is basically a cube.
Yes.
Would the world be more sustainable if everything was standardised and cube shaped? If a little bit less. Yeah. Is it actually kind of the best way forward if we were going to sacrifice aesthetics?
As a conservation engineer, I'd be deeply depressed
if
that was the way forward. As a structural engineer, I mean, certainly, the ModCell system tends towards cube-shaped things. If you want, so if you want a standardised, prefabricated world, and there's a lot to be said for it, then yes, it will tend towards cubes. And I suppose houses largely are cubes. They're cubes of different sizes and different shapes, but essentially they're cubes. And lots of them have sloping roofs, because in this country that's a sensible thing to have. This building here has a flat roof. It's clearly a daft idea, but we will undertake that we have to repair we have to keep an eye on the roof and the waterproofing, because we are absolutely reliant on our waterproof membrane. Whereas if we had a tiled roof, it would be a rather more robust system.
Yeah. So, sorry. Go on. I'll go. So in the future, you see futuristic buildings that are all pod-shaped. That's not really very realistic, is it?
It's not really very realistic, and it would be very sad. I mean, one of the loveliest things about this country is it is a bit higgledy-piggledy and a bit kind of bonkers. And I think, But having said that, there's a joy in the terraced industrial housing as well. So there's nothing actually wrong with the cube as such, and so much of it is about setting, actually. If you've got a row of terrace houses and they have mature trees all the way down, actually you think, that's rather lovely. So there's no reason also why things have to be vastly different, and you do get the sort of places where people, are quite deliberately trying to be different from their neighbours, and you end up thinking, actually, it's a bit of a mess. So there's something about a coherence of materials and a coherence of sizes and shapes. So yeah, it's an interesting. Well, it's town planning, isn't it?
Yeah.
Do you find that people, the main challenge is actually trying to get people to, is the main challenge the social aspect and trying to get people to accept the new kind of type of building rather than the typical city building, trying to get these buildings into the cities, because you don't really see them in central cities.
What sort of buildings do you mean? Sort of
something like this.
Something like this building here.
Do you find people dislike them, or?
Well, this one we managed to slide through despite the fact it's completely different from everything around it, because the planner went, "Oh, it's a bit different, but I quite like it."
Right.
and none of the neighbours noticed, so they didn't object to the planning. I think later possibly thought they perhaps should have paid more attention. But they, I think they like it now and they use it. It's a landmark. So, and we had the classic decision: do you just match the little cottage next door, or do you do something which is obviously different?
Yeah.
And we went for it's got to be obviously different option, and the little cottage next door had already been hacked around really badly in the 1960s anyway, so we didn't destroy something that was still in its original state and beautiful. We kind of shuffled something that was already quite unpleasantly hacked around, so I guess we had more leeway. If it had been a absolutely pristine quarryman's cottage, then again, with my conservation engineering hat on, I would have found it a lot more difficult to do something quite so bold with it. So yeah, I think it's all about setting and it's all about individual place. It's got to be about individual place.
So the ModCell projects, they're in similar sort of areas to this, in kind of,
well, they vary hugely. So, and actually, to date, probably the vast majority of ModCell projects actually have been other sorts of buildings, not housing, but things like schools and community buildings. The thing that changed is at the end of last summer we got what's called a Q-Mark certificate, which is basically a certificate that says that the way that you're building is quality assured and the methodology is good enough that TRADA, who are Timber Research and Development Association, are prepared to say that it's not going to fall down in 60 years. What we're doing basically isn't completely bonkers. And therefore, basically against a Q-Marker certificate, you can then get a mortgage. Because the mortgage providers really don't want to have to look at unusual materials. All they want is somebody else to say, is this bonkers or not? And if the answer is, it's fine, they'll give you a mortgage for it. As soon as you can get a mortgage on a ModCell house, you're away. You're now out of the world of people who can afford to pay cash and into the world of people who need a mortgage. So that's what's opened up the housing market. And that's, I can see a world going forward where housing is half the work and other buildings are the other half. So we're still doing school buildings. We did a school building at a school called Weydon, somewhere near Guildford, which was 6 classrooms, maybe 5 or 6 years ago. And they are now looking at doing a 13 classroom block. They've used ModCell, they like it, it's done very well for them. They've noticed the reduced energy bills and all of those things. They want to build in that system again, and they're talking about, can we do the next block for them? So there'll be a price negotiation, obviously, and things like that. But I mean, ultimately, that they've used it, they like it, and actually the price is no different. It's no different from building in brick and block.
If the price is different, is no different, what is the biggest resistance against sustainable materials being used everywhere, and how's that going to get overcome in the next few years?
I think there's a really natural resistance. There's two things. So one is that when you build in soft materials, you have to be gentle with them. So if you build in a soft material and you paint the outside in a waterproof paint, what lies inside will rot. If you don't let the water out, ultimately it's straw. If it gets wet and stays wet, it will rot. It will turn into a very nice, slightly cosy compost heap. So you have to understand what you're working with. And again, it comes back to the world of conservation. People who live in old houses have always understood that. And people who live in cob houses know that they need to be careful with it, and they need to put lime renders on the outside and not cement renders. But the country has to sort of relearn those skills that our ancestors had, where they knew how to treat materials. We have to relearn. So there's there's a sort of a nervousness which is just about education. It's just about saying, look, they're not difficult. It's not difficult at all. You just need to remember that what's inside is straw, and therefore when you paint the outside, use a breathable paint. Don't use something which won't breathe and won't let the water out. So it's it's just about giving advice and being there and available to give advice. So that's one thing. And the other is all the kind of normal, straw, doesn't it burn? Well, no, it doesn't, because you can't get enough oxygen to it, and you can't. So it's like timber, it chars. Yeah. But you ask those sort of questions, of course you do. That's natural. When you're faced with a material which people don't normally build in, people know that bricks don't burn. They're easy, they're used to them, they know how to use bricks. It's a very easy and confident way to build. Whereas if you suddenly say, well, you could build in these things, people are quite naturally will go, well, hang on. What's going to go wrong? What are the things that could go wrong? And so again, it's more about education than anything else, I think.
James has this guilty pleasure for concrete. Do you
sounded like such an admission.
Do you personally share that, or would you happily see the entire concrete just be eradicated from this earth?
I don't share James's guilty pleasure for concrete, I have to say. I think concrete has its place. I think all materials have their place. I get very cross when people say things are bad materials, because that's just nonsense. There are no bad materials, but there are definitely inappropriately used materials. So concrete is great underground. Other things will rot, or they just simply won't perform. But above ground, you've got to use it very carefully. It is a high embodied energy material, and so particularly as engineers, we absolutely have a duty to make sure we use it where it is best used and don't use it when it's unnecessary. I'm quite a big fan in the kind of about 1850s, everyone was still building mostly in timber, and then they discovered wrought iron, and they went, oh, this is great stuff, but actually it's really difficult because it's enormous amount of energy goes into making steel or iron or anything like that. So they used it really carefully, and the way that they used it was to make kind of like a ham sandwich. So you get timber and timber on the outsides, and then the ham is the steel in the middle, or the wrought iron in the middle, and you make a beam like that. So the steel or the wrought iron is stiffening the timber. So timber is very bendy. If you put it over a very long length, it will tend to bounce around quite a lot. So you use the steel to stiffen it up, but you use the timber to stop the steel buckling. So you make a wrought iron sandwich, a wrought iron timber sandwich, and it's called a flitch beam. But we can do that now with steel and glulam, and that's great because actually it looks really nice. It means you've got timber to timber connections, which are really easy on site. You're using the steel where it absolutely does its best job, but you're not overusing it. You're using it only for where it's really good and for the job it's really good at. So that's something that we're doing. We're now taking a technique that was developed in the 1850s and applying it to modern buildings now, and we do that quite regularly. Actually, flitch beams is something that we use a lot. So I suppose it's just there's a lot of lessons to learn from the past, and bringing them now and realising all those things that we kind of when steel and concrete arrived in the kind of 20s and 30s. It was, it's terribly exciting, and when people are building things like the Penguin Pool at London Zoo, it's stunning bits of architecture, and you can see why architects fell in love with it, and you can see why engineers fell in love with it. It's magic. If you've only lived in a world of timber and masonry vaulting, and it's magic stuff, and you can suddenly do some really interesting things, and we shouldn't lose that ability to do interesting things is great, but we in doing that, making that change, we lost a lot of the techniques that were actually really good and performing really well. So I think there's a world of relearning and of matching those two things together again.
Mm-hmm. James talked quite a bit about restoring buildings rather than knocking them down and building on top of them. Have you done any projects in the past that took that sort of technique? Yeah.
That's most of the world in which I work as an engineer. So, everything from something like Wells Cathedral, where obviously you only ever kind of dip around at the edges and do the smallest repairs that you can get away with, and you're very mindful of the fact that you're working with 1,000-year-old historic fabric and perhaps the first ever use of that particular timber joint in the country, where you're, that's sort of one end of a very sort of green and hairy spectrum of conservation, but through to, say, Trowbridge County Hall, which is a 1960s office block. At the time, it was great, but it wasn't performing for the sort of 2010s. It had low floor to ceiling heights. It was very, very deep floor plates, so people are working under artificial light all day, and that's not brilliant. And it was leaking heat like a sieve. So the project we did there was to take out the ceiling tiles so that you get the full use of, although it's still a smallish floor to ceiling height, you get at least the full use of it. You reclad where you need to stop the heat leaking out of it. We did talk about making a great big hole right through the middle so you get an atrium in the middle and get light flooded right through it. In fact, and then we did the cost benefit analysis of that and decided it really wasn't worth it. But you start to play with. I think those in some ways are kind of the most interesting buildings. The 1960s buildings are really quite difficult because so many of them have this reliance on artificial light, for instance, because it was available in the 1960s. Cheap artificial light is available, whereas if you look at a Victorian building, you don't need light because they're all built around the idea that light doesn't exist, and therefore you use natural light. So you get big tall buildings, big tall windows, and tall floor to ceiling heights. So actually, the difficult ones are the ones that were built in an age where energy is cheap and easy. So if we're now working towards an age where energy is no longer cheap or easy, then we need to start rethinking how you use those sorts of buildings.
How do you think you're going to get people to move into more efficient buildings? Is it through kind of explaining to children early on in education, teaching them about the benefits, or is it just kind of a natural eventually?
I think there is a natural eventually it will go through.
Yeah.
I think certainly it's down to us as an industry and as a profession to make sure that, when a client comes to an architect and an engineer, and they sort of say, we want to knock down this building and start again because we want something new and flashy and modern, your first answer has to be, really? Are you sure? Is there nothing you can do? Let's just take a look at the building that you've got already and make sure that there's nothing that we can do with it. That it might be ever so simple. Actually, it might be taking out some areas of floor plate. There are all sorts of things you can do to an existing building. So I think that has to be the first port of call. Are you sure you need to knock your building down? And ultimately, the answer might be yes, you do. But there are, even 20 years ago, again, Tim, my business partner, was working on one of the BRE buildings, and they used something like, some astonishing figure, like 95% of that building was recycled. And I don't think that figure has been matched. And that's really sad. You sort of think 20 years on and no one else has yet done that thing. But it took some thought, but they did it, and so that there are some things that the profession isn't doing well. It learns these lessons and it doesn't really doesn't then take them on. But I guess these things are gradual, and the building industry particularly is very resistant to change. It likes to do things the way it likes to do things, and you have to kind of push it. Yeah. But there's no doubt that children are growing up in schools knowing that energy is a problem, and so they're coming out of schools going, well, come on, this is ridiculous. Why are we not doing things differently? And so absolutely the push comes from all generations, I think.
And the government as well.
Yes, but massively.
We were actually just talking about at the Bristol Wood Recycling Project. It's a shame that they're not in the debates and not actually talking about climate change and policy they want to implement.
Yeah. Yes, it is deeply depressing, and I don't really know what the answer is. You need to have change from all sides. So, if you want the Green Party to win, you need to go vote for them. But on the other hand, until we have proportional representation, it's really difficult to see why you would vote for them, because because they're never going to get in. And so therefore you end up thinking, well, hang on, if I vote Green, is that a wasted vote in my area? That's
the people say that, but then if everybody who said that voted, then it would have an effect.
Yeah,
but
absolutely.
It is a that's the point.
That is the issue with the first past the post system, isn't it? And if I think the Lib Dems have done quite well in government, considering I think they've done a lot of learning, and I'm sure if they ended up in coalition again, they would probably do it very differently. But The one thing that they didn't do that would have been a major triumph is get proportional representation through. And I'm sure they're kicking themselves, and I'm sure that if they get another go at it, then that might be something that they push for really hard. It would be if I was a politician, which I'm not.
Do you think there will be a point in the next 20 odd years? Do you think it'll happen in the next 20 years whereby environmental sustainability becomes the number one focus, like within construction and within the rest of society? Like, is it the number one focus now in building, or is it still cost or other things like space?
That's a good question. I think in the world I'm working in, it absolutely is the number one focus. But my suspicion is that I'm working in quite a privileged end of the industry. So there's an awful lot. There's a huge swathe of the industry that actually doesn't give a monkeys and is still going to profit. If I think about the things that actually really worry me on a personal level, it's fuel poverty and food poverty, actually. I think those are the things that... ultimately there will be some cataclysmic moment when the whole thing just goes completely wrong.
Which could be great. Could be a great thing.
It could be a great thing. It could be appalling while it happens, but it could be a great thing. So, and the tragic thing is that might be what it takes. And I do hope it doesn't. But...
Yeah, and it's funny you should mention that. I just mulling something over. Do you think rather than attempting to rather than putting so much effort into reversing the current situation in developed countries where you have mass urbanization with concrete and steel, you would be better off focusing your efforts on places, say like rural parts of India or in China, where you are getting more and more urbanization? So you could do it from the ground up rather than having to start all over. I'm
sure you need to do both. You need to do both. I'm sure there's no doubt that we should now be going to China and India and saying, just don't repeat these. These things we've done. They're foolish. Don't do that. Here are some other things that we found out. You need to develop your ways of doing it, because one thing you can't do is impose ideas on people. It doesn't work with small children. It certainly doesn't work with countries. But what you can do is persuade people that there are better ways, or that the ways that surely you can learn from history. Surely we can learn from history. Well, probably we can't, but I'm sure you need to do both. Yeah.
China at the moment are definitely not being well. I don't know if they're doing even worse than us. I watched a documentary recently on the smog.
Yeah,
it's atrocious.
Yeah, absolutely, and it's really sad. It's really sad to see people simply repeat it. It's only a repeat of what happened in London in
he was saying
the
that
1850s and earlier. But how you get that through without being patronising, it will take some great politics. It would be interesting to know if there are places in China where it is being done right, and because that would be the way to get the word out. I would have thought it has to come from within.
Did you see the tokenistic ionizer that they put in Beijing? No. They just put it. They were going to put a massive one in, and instead I think they scaled it down many times, and then just put it in a public park. So you have one small tiny section of the city where it's just that.
It's basically cleaning up the air.
Yeah, but then everywhere else it isn't. Sometimes it seems like the not just civil engineering, construction is a lot like that. You have these wonderful, fantastic projects like Passive House, that sort of thing, but then so much of what you see actually going up is still concrete and steel. Do you never find that slightly disillusioning?
Yeah, absolutely. It's deeply depressing. It's deeply depressing, and actually, it's kind of an interesting thing, isn't it? At the moment, ModCell is growing out of being a little tiny research spin-out to being a company which is standing on its own 2 feet and starting to build some stuff, and that's great. It's lovely to see it going from being a crazy research spin-out to being a proper company in its own right. But actually, quite shortly, it will face a dilemma. Should it now go carry on doing a gentle organic growth, taking the interesting and lovely people that have taken it so far and are now running it, should they continue to grow it, or actually is there a sort of duty to the world to say, if you really, really want to change the world, what you have to do is get some big nasty investors to back this company and go actively pushing it and selling it to every house builder in the land. And you completely change. As soon as you get investment from outside, from the big nasty world of business, you fundamentally change the way the business will run. You fundamentally change its ethos, probably, unless you're incredibly lucky and find a knight in a white charger who has an ethical basis as well and who absolutely puts that in behind it. But, chances are if you really push it, you've probably got some kind of really solid financial, and that means possibly slightly unpleasant, finances behind it. But do you save the world quicker?
Yeah.
I don't know what the answer is to that, but that's
a certain way at this point. In which ones?
For me personally, and I'm bearing in mind I'm one tiny shareholder. So, for me personally, I think it's a real dilemma. I mean, the ideal obviously would be to find the right kind of investor and push it out. But I do think there was something in ModCell's stated aims at the beginning of its life, that it wasn't going to be just a diddly research company doing something kind of interesting and not really getting beyond a few houses, because so many research projects fall down at that hurdle. And so, I think there is something to be said for somehow or another getting that thing out there into a much bigger world a lot more quickly than it will be if it grows organically. I think there's a possibility.
Are the readily kind of established farms, are they moving towards more renewable materials like ModCell, or is it mainly research, kind of small startups?
Do you know, what's really interesting is that it tends to be very small bits. So we are working at the moment with Skanska on a research project. So Skanska, massive multinational company. Yeah. We're doing some work on prefabricating. So the methodology that we built within ModCell, which was all about prefabricating, but prefabricating very locally. So rather than taking large boxes of air all around the country, we get the bits together on a local farm or a local place, a local business park, anywhere where there's a shelter. You put the bits together, ideally within 5 to 10 miles of your final building site, and then you take the pieces in when you're ready. So that was what we call the flying factory. And it worked very well. It's very low capital outlay. You can do the bits that you need to do, and you're not shipping boxes of air around the country, which is definitely a winner for all. Skanska said, well, that's an interesting idea. Why don't we do that with other bits? So we could do that with, I'll tell you what, why don't we do it with all the M&E units? So we'll make a little kind of like a mini plant room for, I think they're doing it for housing at the moment, where they put the boiler and the electrical cupboard and all the bits and gizmos, and they're putting all that together in a little flying factory and taking the complete unit to site. So when you're on site, it's ever so quick. You just literally plug the boxes into each unit, and all the work, all the connections and all that stuff is done close by, but not actually on the building site. So they've kind of taken the idea and translated it. They've kind of, and some things have gone well and some things have gone not so well as you'd expect, and that's fine, and that's part of the learning process. But will it last beyond the end of that grant-funded project? We're not completely it'll be interesting to see whether it does or not, because the reality is that the chap who's in charge of it will go on to the next research project, because that's his job. And all the folk who've actually done the do will say, well, it was all right, but it wasn't brilliant, and it actually was a bit disruptive, and I like the way I've always done it. And all the learning will get lost quite rapidly. So the big companies aren't necessarily any better at then taking that learning and saying, right, okay, let's do something really interesting with this and ship it out across the whole of Skanska worldwide. There's a very high chance it will fold into a small ball and just be, well, that was an interesting thing, put the book on the shelf and never touch it again.
So is it just that they're not really interested, or is it they're making enough money with concrete and things like that?
Yeah.
They have no.
Well, they know they're going to make money with concrete.
Either way, and so it's it's always going to be easier to do stuff the way you know how to do it, and it's always going to be harder to change.
Yeah.
Making change is difficult, and in some ways, the bigger you are, the more difficult it is.
Yeah. So the materials you use at the moment are kind of traditional materials, effectively.
Yeah.
Do you they are? You said that they can be affordable. Do you think maybe in the future when everything's utopian, it will be brand new materials that are significantly cheaper? Because I think it's competitive, but it's not like significantly cheaper, which is the driver for most people, I suppose, ultimately, than concrete or steel or brick or anything.
You see, in my utopian world, you don't necessarily go for bigger or more.
Right.
I think you possibly go for smaller houses.
Mm-hmm.
We always say we don't use half of this house. Frankly, you could knock off that half altogether. We live in this room. we sleep in the rooms downstairs, and actually the rest of it, I think now, well, maybe it wasn't necessary. We're kind of overusing space, and I'm sure that's not unique.
Yeah.
And I think, so actually maybe cheaper doesn't matter so much. I think quality has more to do with it.
Okay.
If it's good quality and it lasts a long time and you love it, slightly go back to if it's not beautiful or useful, get rid of it approach.
Yeah. So these materials will hold up, you think,
Yes, I think they probably will, because I think the reality is it takes, you still need space to grow straw, or to grow a crop from which straw is a byproduct. You still need space to grow timber. You still need a lot of energy to make a piece of steel, and a lot of, that will eventually one day surely run out of gravel to make concrete. The materials will become more and more and more precious, not less and less. Mm-hmm. We'll get better at recycling it, I'm sure. We are better at recycling it.
I mean, we've talked a lot about timber and straw and bale. What is it about those materials that is so much better than the concrete, the steel?
They're renewable.
Yeah.
I mean, basically, but it's really, it is that simple. If I put a ModCell panel on the compost heap, it will compost down, it will become the earth, and there's nothing in there which is unpleasant. It doesn't have chemicals in it. There's nothing in there. So it will go back to the earth, and you can spread it on the fields, and you can grow, another field of straw and another wood of timber. So it's it's really very simple. The bit that's not renewable in a ModCell panel is the screws. Mm-hmm. So my goodness me, you take the screws out and you make sure you reuse them, and you use screws rather than nails.
Yeah.
Even then, the reality is you probably don't reuse the screws. What you do is melt them down and make new screws. But at least the component parts are relatively easy to pull apart.
Yeah.
The problem with something like concrete is that it will only ever go downhill in value. So you'll take a concrete building and it's useful as a building, and then you'll crush it up and it will become road fill, and then you'll take the road fill and you'll chuck it into landfill because there's nothing else you can do with that, because now it's contaminated. It's not just full of concrete, but it's full of bits of petrol and goodness knows what else has soaked through it over the years of being a bit of underlay in a road. And so it's degraded and degraded and degraded through its life, and it's just becomes less and less and less useful. Whereas if you take something like a brick, if you put it in a lime mortar, you can then reuse that brick. But if you put it in a cement mortar, you certainly can't. So there's definitely still, there are things. Lime mortar is wonderful. I love my lime mortar. So lime mortar means that you don't need to have movement joints every 6 metres because it's soft and it carries on being soft throughout its life. Those things where you see a garden wall and every 6 metres there's a kind of nasty, gungy line of, you'll see it now when I've said it. Yeah. You go have a look. A sort of nasty, masticky joint every 6 metres in buildings and garden walls all over the land. And they're just vile, ugly, horrible things. And in engineering terms, just a pain in the backside because they're a straight joint that that now you've suddenly got a wall that wants to wobble at that point. If you use a lime mortar, you can go for as far as you like. You can go hundreds of metres in a lime mortar, and because as the brick or the stone or the concrete block expands and retracts thermally, the mortar goes with it. No need for movement joints. So suddenly you've got this lovely thing, and when you come to taking it apart, you can take it apart, the lime mortar knocks off, you can reuse the lime mortar, you can reuse the block, job done. So suddenly you can build them. There's nothing wrong with blockwork and brickwork. The problem is that when you come to take it apart, if you used a cement mortar to stick it together, again, all you can do is crush it up. Whereas if you use...
Sorry.
If you use the right kind of mortar, you don't need to do that. You can reuse it.
Mm-hmm. I always assumed they were amateur builders.
Yeah, everyone has to do it. Yeah. You mentioned near the start actually the idea of a carbon negative building.
Yeah.
How is that possible? And if you take absolutely everything into account, is it still true?
Yeah. Well,
true, yeah.
like
computer power usage, all that sort of stuff.
Yeah, absolutely. Probably not really. I mean, it's people say carbon negative when they take into account the sequestered carbon in the thing. So, Uttery holds so many tons of carbon, but of course, if you do a cradle-to-cradle analysis, if you do a cradle-to-grave analysis, that works. Mm-hmm. If you do cradle-to-cradle, which is what we should be doing, then obviously, as soon as you've chucked your ModCell panel on the compost heap, it releases the carbon again.
Yeah.
So it's not carbon negative at all. It's carbon... the panel itself will be carbon neutral, but of course you're right. You've used up all the energy in transport, all the energy in computer power, thinking about it, lighting the thing while it was a thing, all of that stuff. So it's not really carbon negative, but so you have to be quite careful with the terms.
Yeah.
I think you do have to be quite careful with the terms.
It's a good goal to aim towards, even if it's quite arbitrary.
Absolutely. But certainly, we should be designing buildings that are self-lit. We're in this building now, and there are no lights on. Because but there's a balance between having no lights on and how much heat leaks out through these windows, because they're only double glazed, not triple glazed. Have my time again, or when we get to replace them, we'll probably go for triple glazed. But you live and learn, and everybody moves on. So yeah, you kind of it's always a balance. It's always a balance.
In industry, have you always worked with renewable materials, or did you start off by working in traditional stuff?
As it happens, I started off working in traditional stuff. I didn't really think about my career very hard when I left university, but so the job I was offered kind of sounded interesting at Alan Baxter's in London, who primarily do conservation work. So I kind of fell into it and pretty rapidly fell in love with it. But actually, so my introduction to modern buildings actually came much later. And in fact, I personally design very few modern buildings. Mostly what I do is the old stuff still, but my colleagues do the new stuff, and because we knit them together, we learn from each other. So if I've got a new piece of an existing, if I've got a new piece, I know I can get it analysed really carefully, and it's quite a different way of thinking. So if I'm analysing an existing building, there's a starting point which says, has it stood up? Oh, it stood up for 300 years already. How much do I really need to analyse that thing if it stood up for 300 years already and I'm not changing the use? So you do very few sums. That's one of the attractions for me of conservation engineering. Significant lack of maths. Occasionally I'll do a timesing sum. Sometimes I might do an adding up sum. And if I've got to do a properly timesing sum, I might ask one of my colleagues to do it, because I can't remember how to do it anymore, because I haven't used it really. Because there's no point doing a really, really complicated sum on a beam and then discovering it's got a whopping great knot right in the middle of it, which completely changes all its characteristics, because it's an utterly different kind of a thing. A medieval building is not the same as working in steel. It's not homogeneous, it's not predictable, it's not remotely it's whatever it's going to do, it isn't going to be what you predict it's going to do. So there's a lot more instinct and looking and thinking, and not finger in the air. That wouldn't be a fair assessment, but there's a lot of experience goes into it. Where are the issues going to be? How are they going to be? Where do we find them? How do we look for them? And what do we do if we think there's a problem? It's a very different mindset.
I think that's quite... I don't know if it's frustrating or refreshing to hear, as we're all engineering first years. I'm not a massive fan of the maths myself. Like, you think actually once you get into being kind of a successful engineer and doing the things you love, it's about more than your knowledge of engineering theory. It's like you do things you love and you're able to...
Absolutely.
Kind of, yeah.
I think engineering is marvellous, because you can, from an engineering degree, you can go in so many different directions. And for those who absolutely love the maths and love the computing side and love that, there's a career there, absolutely, without question. But for those who discover that actually the maths is okay, but it's a tool, and actually what they really like is the politics and the people, there's equally a career, and they're equally valid careers, and they're equally useful and necessary careers. And actually most engineers, of course, sit somewhere in the middle of those things, but it's such a broad thing, and I think engineering at university tends to get very bogged down in the you must know these things, and of course you must know those things. You can't speak with authority if you don't really know what you're doing. But actually, once you've done your apprenticeship, the world is your oyster. It's marvellous. You can do anything with it.
Is there anything in particular that you wished you knew when you were studying? Looking back?
Oh, that's quite tricky.
About the industry, or...
I think I've I don't know. Things I wish I'd known then. I suppose it might have been quite heartening to know that it was such a broad career when I started. I mean, I didn't... I kind of fell into it. It's fair to say I got my first class degree in rowing and my not quite first class degree in engineering. So I don't think I quite paid it the attention I should have done at university. Having said that, I ended up in the right place anyway.
Yeah.
So do I regret it? No, not in the least. No, I had a brilliant time. But if I'd paid more attention, I'd probably still have taken the same career path, actually. And there's and I do think there's an element of, you know, your luck is as you make it. If you work hard, you will find a path which is interesting. And what I was thinking actually just before you guys came, I was thinking, you know, there are several different bits. I chose a career in engineering, but I could equally well have, you know, every so often I kind of think maybe I'd like to have run a small holding, or perhaps I'd like to have coached rowing for the rest of my life. I could have done any of those three things, and in fact, you know, but I don't regret having chosen. I could have equally done any of those three things, and probably been sitting here saying to you, I'm really happy doing it. So I think most people have lots of different sides of their personality, and most people could do lots of different things. All you can do is pick what seems right at the time, and be prepared to shuffle and change as life shuffles and changes.
Do you think the exciting things that are going to happen in the next however many years in engineering are going to come in small businesses like yours, come in startups? That's what's happened in the tech industry, I suppose, the high-tech computing industry.
Absolutely.
Is that the same within physical
I think
engineering?
it depends very much on the company. So yes, I think probably the most interesting things are happening in startups, in startups and in little companies. But I think also there are some incredibly dull little companies who do what they do, and they do it well. They've always done it, and you know it's an easy way to make a living, and they're never growing and they're never going anywhere. And they do perfectly adequate engineering, but it's not very exciting. So I think it's small doesn't necessarily mean exciting and bijou, but it can mean very fleet of foot. I mean, you know, there aren't many big companies who could have said, sure, we'll invest in ModCell. Crazy, brilliant, go for it, do it, just go for it.
Yeah.
Because they would have, you know, they're stuck with their processes and their policies and their shareholders, and they're having to make a case for it. Whereas obviously, you know, Tim Grant and I sat there and went, oh, why not? What's any money? It's money and it's time, but actually, why are we in this? Do you go into engineering to make lots of money? Not really. You know, if you want to make lots of money, go into banking, become accountants at the end of your careers, at the end of your degrees, and you know there are plenty of ways to make lots of money. Do we have enough money to live on? Certainly, more than enough money to live on. You know, none of us can say that we're on the poverty line, so therefore we might as well do something interesting and exciting with our careers and our lives, and it's exciting for our staff, and it's exciting world to be in. I'd rather be doing ModCell than sitting here comfortably knitting in the evenings. I mean, it might be crazy, but it's fun. So yeah, I think the small companies are fleeter of foot, but you have to be careful to pick the right ones or start the right ones.
Yeah.
I mean, just being small, it's easier to kind of control where it goes, whereas big company, it seems like the people don't really matter in it. It's just more kind of, even if the same people who are working there leave, just more people will file in and do the same thing, really.
Yeah, I mean, I think it's probably slightly harsh on the big companies. I think they can be like that. I think that, I mean, there certainly are big companies that are like that. But there are certainly those who actually put quite a lot of time and energy into their staff. But you're right. I mean, ultimately, yes, of course. If you're the head of a company of 130 people, you no longer know the names of their wives, the names of their children, the names of their husbands, the names of their parents. You don't know that their dad's just been diagnosed with cancer, and actually that person's going to have to take a week off to go home. Yeah. Whereas obviously in our company we still know that, and I quite like that. I quite like that I know, that it's still exciting when one of my staff members has a baby. It's just like, wow, that's just really exciting. But when you've got 130 people, inevitably you're going to be marginally less involved on every individual's day-to-day lives. Having said that, of course, big companies split themselves into teams, so that on a team level, of course, everyone does know the wives, the girlfriends, the husbands, the kids. So you get different things from big companies and little companies. They're just different. And people thrive in different sorts of places. So, ultimately people have to pick their own, pick what suits, don't you? And that's the other great thing about engineering, is that there's so many different kinds of companies. All you can do is go try. go try out small places, go try out big places, make the most of holidays, make the most, go to every opportunity for work experience that you get and see what feels right.
Yeah.
And then, if you make the wrong decision, we'll just change. It's not the end of the world.
How many people work at ModCell and Integral?
At Integral, I think we're 16. I should know that, shouldn't I? Just count desks.
Is it all?
But you know every one of them.
Yeah, I know. I do. I just don't spend my time head counting. At ModCell, we've got one full-time person, 2 part-time people, 2 more part-time people. That's me and Craig, and we need more. So this is still quite a little team, and so it's growing quite fast. So that's actually probably within the next couple of months we'll have 3 full-time people. That's the kind of, it will grow quite rapidly.
And is it only structural engineers, or do you also have architects or part of the company?
At Integral, we have only engineers and support staff that go with that, of course. So yeah, some amazing support staff, absolutely amazing. Yeah. So people with their own perfectly very valid careers.
Are you ready to? Should we do the final 2?
Oh, hold on.
Go on.
I had a tangent that didn't fit in anywhere. It was actually about when you worked or you still work in conservation, obviously, but what's the most frightening situation you've ever discovered with an old building? Or have you ever discovered a spire about to fall down, anything like that?
You should say that one. So I had two. One was at Middleport Pottery. We went into the room where they'd kept so when you make pottery, you pour, the way they make pottery, this is one of theirs. So when you make a cup, they have a mould for this, and they pour the slip clay, so it's like a liquid clay into the mould, and then they take the mould off, and there you are, you have a cup. Or actually the plates they do slightly differently, but anything like a cup or a jug or a teapot or anything which has an intricate shape. And throughout their history, they've made all sorts of things, so fabulously ugly Toby mugs and, caricatures of all sorts of people and politicians and, all these sorts of things, crazy items of Chinaware that none of which you could possibly want to buy ever in a million years. And every single one of these moulds they've kept. So it's like it's 140 years of moulds. And these moulds are some of them are massive. They're kind of, I'm indicating with my hands to the radio, so I'm maybe, some of them are 2-3 feet high and a foot wide. They're vast things and really heavy, and they're all stacked on bookshelves. So we went into this room basically full of bookshelves, and the room, it's so heavy that the feet of the bookshelves are punched through 2 layers of floorboards. And Kim and I went into that room, and there was just something about it that didn't quite feel right. And we kind of went, this just doesn't feel right. And we went back to the office and we did some sums, and we went, okay, so we know the building has been standing up for 150 years. However, those beams are 4 times overstressed, theoretically. At any moment, any one of them could go pop. So please, could you put some acro props in really, really quickly? The issue is, of course, that we can acro prop the overall floor to make sure the whole building doesn't fall down, which is definitely an advantage and a step forward from where they were. What you can't do is unload the bookshelves. So you've now got bookshelves on racks that are absolutely going to fall, at any moment, again, another foot could go pop through the floor. But we've somehow got to get these priceless moulds out of this space. So we ended up writing a method statement that had one person not breathing, moving very softly around this room and handing the things out of the window. It was just, but literally the day before, they'd just been kind of pounding up and down there, chucking stuff in, adding more moulds to the pile, and you just think, that's just crazy. And then the second one was standing on a bell frame, looking down in a bell frame of a church spire, looking down and going, that's not very well connected. This thing I'm standing on right now, suddenly I'm not feeling very happy about it. So I kind of got out of that space quite quickly and wrote a risk assessment or updated the risk assessment I had previously written to include the fact that the bell frame is deeply, deeply unstable, and could we please not go into that space again, and then close the church. Let it go, which it hasn't to date, but they've now got the grant funding, so we basically went back to HLF and said, whatever grant funding you have given this church, it's about half of what it needs to be. Please double it, or we'll simply close the church.
Mm-hmm.
And they did. They turned around and said, "Yep, sure, fine, okay." Double the grant funding, set. That's a project ready to go. But that then beat the archive storage, my scariest moment. So yeah, there are some scary things. Particularly in the world of conservation,
Mm-hmm.
obviously, because that's. So yeah, we have a lot of very careful training about how you enter a building like that.
Wow.
What you look at, where you don't step.
Okay, yeah. We just have the last two questions which we like to ask
Okay.
all our guests. The first one is, looking to the next 20, 30 years, what are you most excited for?
Ooh.
Can be, personally, globally, to do with your company, anything.
Golly, that's quite a wide question.
It's about as broad as it gets.
It is quite as broad as it gets. Okay, well, company-wise, so ModCell I'd like to see grow into a proper whole company all of its own. That's definitely an exciting world, because that's completely different from anything I've ever done before. Taking a startup and, it has the potential to go global. It's, it's an amazing thing. That's bonkers. But so we'll see. Integral will grow organically, I think, and very happily, and I would like to see it do that, because I think it's got some great ideas, and I think there are very few companies that truly merge the worlds of conservation and new build. And if we can grow it and keep that ability to do both, and do both really well, I think we are currently, I think, pretty, we're unique, and I think I'd like to see that getting better and better. Personally, I'm going to retire and get my micro pig and my chickens and do my second career, the small holding one, and I'm doing a bit of rowing as well. So maybe I can just get out of engineering altogether and scratch my micro pig in the morning and go coach rowing in the afternoon.
Sounds better.
I might give another 10 years.
And then the final one is, what are you most worried about?
We did that before.
Yeah.
Fuel poverty and food poverty.
Yeah.
I mean, genuinely, the things that keep me awake at night when I worry about my daughter's future, it would be that politically the world goes pop because there isn't enough food and there isn't enough fuel. So yeah, that's the thing that keeps me awake. Not more than nuclear bombs used to when I was when I was growing up. It was a bomb, and now it's food. So yeah.
It must help in some way that you're working in an industry that you're actually actively kind of helping the world.
Yes, absolutely. I mean, if I look back at my career and I think of the things that I'm proud of, that is one thing that I, if I get really passionate about something, I'm proud of every second I've spent at ModCell, and sometimes it's been really painful. Every tiny business, particularly startups, particularly research companies, go through, it's called the Valley of Death. So you've invested a huge amount of time and a huge amount of money and a huge amount of energy into this thing, and nothing appears to be happening. And that's the moment where most startups go crash, because you just can't see the end of this kind of appalling black tunnel of stuff. And we've gone through that and come out the other side, and we can see that there is a future, and it is starting to be seen and known, and I'm really proud of that. I didn't do it on my own, but I did with a team around me. We've collectively taken a really good idea and actually made it real, and that's amazing. Great place.
Brilliant. Thank you for joining us in the episode, and thanks for listening.